Today we're going to be talking about limits with regards to an introductory calculus course. In general, the limit as x goes to a of the function f of x equals some number L. So if we're saying that f of x is defined when x is near some number a, then that means that f is defined on an open interval that contains a, but not necessarily a itself. And I'll show you what I mean here. We're going to start off with a very simple example. In this example, a equals 2. And if I want to take the limit of this function x plus 1 as x goes to 2, I can simply see how the function is behaving around x equals 2. And so maybe I'll plug in the number just to the left of x equals 2, so 1.999, and I'll evaluate that, which happens to be 2.999. Similarly, if I use the value just to the right of our point of interest, 2.001, let's say, and evaluating the function at that value, I just get 3.001. These two numbers are very close together. And so what I did here was I had approached the limit from the left, and then I also did it from the right. And there's a notation for this. Specifically, as x goes to a from the left, that's the left-hand sided limit. The limit as x goes to a from the right has a positive subscript. The two-sided limit criterion says that the limit only exists if the left-hand sided limit is equal to the right-hand sided limit. In this case, the limit exists. Let's try a different one. Let's try a rational function. Let's try recognizing that in the numerator we have a difference of squares. Further simplifying this, we can't forget about this domain issue here. Great. Now what if you're asked to evaluate f at x equals 2? Can we do that? Right here the function just says x plus 2, but we do have this domain restriction. Are we completely lost? No, we're not. We can continue using the concept of limits. So the function itself is undefined because it results in division by 0. However, we can take the limits, left-handed or right-handed. And if we graph this, we know that it's simply x plus 2, but x cannot equal 2. So that's just a line with a slope of 1, shifted to the left by 2 units. Something like that. We know that we have a hole in the graph. What taking the limit is doing, and if we do it from the left, and we do it from the right, we can ask ourselves, does this limit exist? And in fact, we can just see that as we approach from the left here, we approach this value of 4. Similarly, if we approach from the right, we also arrive at that same value. And so this limit exists because this is true. This equivalence is true. The left-hand sided limit is equal to the right-hand sided limit. Just to hammer this idea home a little bit further, I'm going to do an example, a counterexample, I should say. Okay, so we can see right here that if we take the limit from the left, we get this function value at this hole, and let's call it some b. And then let's go from the right. As we approach our point A from the right, we end up getting a different value, not b, we get c. Well, because c does not equal b, that means the limit as x goes to a from the left does not equal the limit as x goes to a from the right. And therefore, we have no existence, right? The limit does not exist. So essentially, the limit is a tool that we use to observe a function's behavior at a point where the function is not necessarily defined. And I think that that is a good introduction to limits. If you have any questions, leave them in the comments. And if you would like to request anything I cover in the future, leave that in the comments as well. Thank you for viewing, and I'll see you guys in the next video.